Yeah, you got just a couple minutes. Sorry, just ignore those papers on your desk. Did you go to the pep rally or go to the cafeteria? Isaac, I'll be back. Hunter.
the pep rally?
Yeah.
Did?
Yeah.
They were advising us to go to the bottom features, which I don't think anybody listened to. So.
No, I wasn't in the bottom features.
What's that circuit? I think the last question. I mean, I knew the answer, I just didn't know.
Hey guys, it's true. Were you up here? Okay. Abby was, right? What did I get? Yes. That's a shocker. I'm always gonna give it. Oh wait. They call me Austin Phillips. How do I know? My middle name. Yeah. Yeah, that's too bad. Yeah. Not Austin German.
Is it Thompson? So I just want to put my work. Yeah, for like all three.
I'm looking at my 100. Believe it or not. I think that might be true.
Freaking English teacher gave us a quiz and I never did it because I didn't realize she gave it.
Okay, good morning guys. I need assignment 78 and 79. We did 78 together, so there's no way that one shouldn't be finished, but 79 might have been a little bit of homework. Make sure your name is on each and come give those to me, please. Okay, while you guys do that, I guess I do need to warn you that I think we are getting close to the end of the unit here. Obviously, we will have a full review day before the test, so it's not going to just sneak up on you or anything. But I think and I need to double check, but I think the last thing from Unit 6 that I need to share with you is what we will talk about on this first handout this morning, 81. So we're going to take about 5-10 minutes to talk about the difference between integrating a derivative versus deriving an integral. And then two of your handouts were some practice FRQs. We are not going to take the time out to do all 4 of those today, but I am going to do one of them for you and ask you to do one as practice. The other 2 will be for another day. And then we'll finish up with the short circuit that focuses a lot on distance and displacement to make sure that you have that stuff straightened out before you start to see those questions on the test. So that is our plan. Again, I know Pep Rally ran a little bit late, so if you guys just got here, make sure you come bring me your 78 and 79 here at the start of class, please. Just up to the basket over here. I need those in the next minute or 2. Okay, So 81, half of 81 is stuff that we have already done. The second fundamental theorem of calculus. And the second fundamental theorem of calculus is like questions 1 and 2. So these first 4, I'm going to do one of each type for you. And then the bottom half of this worksheet, I'm going to ask you to try them real quick before I go over them so that you can see if you got it or not. But 1 and 2 are the two that you have practiced for multiple days now. If you want to take the derivative of an integral and the bottom's a constant, derivative of an integral and the bottom's a constant, then basically the derivative and integration cancel out, but plug the upper limit in everywhere there's a variable. So the f of t changes to f of x, and the f of t changes to f of x squared. Now, one of those is correct and one of those is not correct. So which one is not correct and what did I forget?
X squared, you've got chain rule.
Right, so sometimes you don't need it, which is why sometimes students forget it, but make sure you're training yourself to multiply by the derivative of the upper limit. If you didn't think about it here, you got lucky because times 1 doesn't do anything. But if you don't think about it here, it would be wrong. It would be times 2x. So, again, I've tried to give you pretty much as much practice as I have on the second fundamental theorem, other than a couple practice questions on the bottom of this page. So, if you still aren't picking up on that pattern, you need to maybe retry those Khan Academies a few more times. That's meant to be an easy way to do those. Okay, but now the purpose of this handout is to show you what if it's the other direction. So now I'm not taking the derivative of an integral, but I'm integrating a derivative. Unfortunately, those they don't work exactly the same. So at least for this first question or two here, I'll show you the long way. So I could do the derivative of f first, which we could call f prime. And then to integrate, I need to figure out what could I take the derivative of to get f prime, and what would that be? F. So it's like these two are canceling each other out again. This is derivative, but then I'm undoing derivative, so that's why it goes to this and then turns right back around. But we still need to worry about evaluating from 2 to 5. So the answer to this, obviously you plug in the 5 first, the 2 second, and then subtract those. So there's one without chain rule. Again, you could just physically say the derivative of f is f prime. The antiderivative of f prime is f. Evaluate from 2 to 5. I feel like when there's no chain rule, it's pretty easy to follow, and you could just do it on the fly like this. You probably don't need to memorize this. But, exact same question, if there's a 2 here, when you do this derivative, this is not just f prime of 2x. Because of chain rule, I'm taking the derivative of something where the derivative of the inside is not 1. So you would have to multiply all of this by 2. And then, of course, integrating a derivative. This is just saying, like, what could you take the derivative of to get f prime of 2x? Well, that would be f of 2x, but it still needs to be evaluated from 2 to 5. So plug in 5 the first time, you'd get f of 10. Plug in 2 the next time, you'd get f of 4, and then subtract in between. But right here, there's a chain rule created on the derivative step. So that part you need to be a little more careful on. It's a lot harder to miss it on 3 than it is on 4. Okay, so below this, finish copying those down. I've got like 8 questions or so where they are a mixed bag of this. Some second fundamental theorem with no chain rule, some second fundamental theorem with chain rule, some integrating a derivative no chain rule, and a couple integrating a derivative with chain rule. So I would like you to try those on the bottom, commit yourself to an answer, and if you're getting all those right, then I wouldn't worry about it again until maybe the night before the test or something. But if you're getting them all wrong, then you might need to ask for some clarification in a bit. So let me give you a few minutes to put down some answers there. Okay, just a moment more. Okay, so here is, I'm going to go over all 8 super quick, and then I will give you a chance to speak up if I went over any of them too fast. So, the top 4 are the second fundamental theorem of calculus, derivative of an integral where the bottom's a constant. So, number 5, you just had to plug in x. F of x should be your answer. Number 6, you should just plug in x. X to the 4th minus 9x should be your answer. They should no longer be y's. 6 looks a lot like 5, but you plug this in, f of 2x cubed. This one needed chain rule though. The derivative of the upper limit is not 1, so don't forget that you need to multiply by his derivative. This one, the x squared, can get plugged in for all the t's, so that would be 5x squared minus x to the 4th. But once again, times a 2x. That one has a chain rule step. I'm going to highlight all the chain rules. Okay, you've been doing those for a couple days, so hopefully you felt a little better about those. If you want to integrate a derivative, again, sometimes you can just do the derivative, then turn around and undo the derivative because of antiderivative, but you're still going to have to plug in the 4 and the 8. So this should have come out to be f of 8 minus f of 4. This would have been f of 10 minus f of negative 2. Again, these are basically canceling out, but since the integration's on the outside, we still have to deal with the bounds. You could do the same thing for question 8 and question 8. You could plug in a 9 the first time, and then a 1 the second time, and subtract those. But this one has a chain rule step. This very first inner part, when you take the derivative of f of 3x, it would be f prime of 3x times 3, because of chain rule, so it would create a 3 in your answer. Same over here. This one gives you a chain rule step of 2. Otherwise, you get to just plug in the top one to get f of 6, minus plug in the bottom one to get f of negative 14. So again, these patterns are meant to be time savers. They show up often enough that we should recognize the patterns so we don't have to do them by hand. And both of these will be on your AP exam. And obviously, compared to some stuff we have to do, you know, I can go straight to the answer on these. It's nice that I don't have to do 4 or 5 steps. Okay, is there anything you would like to quickly clarify about any of these 8? Yeah.
So do you just take the chain rule from whatever is like on the top of
For these first 4?
Yeah.
Yes. It's always times the derivative of the upper limit.
Not like the actual like numbers that you get. Like you don't worry about that.
For these?
Yeah.
No, just whatever the derivative of this is, multiply derivative of this, multiply derivative of the upper bound, derivative of the upper bound. You don't need to plug any numbers in. Okay, other questions? Okay, next up will be the 82. Oh, these haven't changed. Okay, what I would like you to do, just very briefly, do this. Sorry, I didn't have a copy of it up here. I'm still looking. Just gonna have to use this one. Okay, so there are 4 FRQs, and what I'd like us to do with class today is I'd like us to look at 2 of them. So one of them I will ask you to try with the timer set, and one of them I will start off by going over it with you / for you. So I don't care which one we do together, so I would suspect you would probably pick the one that you think is the most difficult. So I'm going to call this is what I'm calling the first one. So just kind of skim through it. The one on the back page, I'm going to call number 2. The other page has question 3. And then its back page has question 4. So skim all 4 of those, and if you have a preference which one of those 4 we do together, then I will give you a chance to raise your hand and vote. Again, I would suspect you would pick out the one that looks like it would be the hardest, the one you would need the most assistance on. And then once we do that together, I will let you pick the one you want to do on your own, which I'm going to suspect you're going to think is whatever you think is the easiest. So again, don't read them completely, just kind of skim over them, just think about which one looks the easiest and hardest to you. Okay. If you would like us to do question 1 as a group, go ahead and raise your hand and I will total those up. Anybody think this one looks like the hardest of them? Okay. On the back, does anyone think this one looks like the hardest? Number 2. If you have no preference, then just don't vote. That way people who do care, their vote counts with it. Okay, did I see one hand for 2? Okay. Number 3. Particle moves along the y-axis. Anybody think that one looked the hardest? Okay, we got 2. And what about number 4? Okay, nobody thinks 4 is hard, so. Okay, we can do this one. It's interesting to me which I'll pick compared to the other classes, but. Okay, so let's go over this one together. We'll talk about the scoring. Again, the closer we get to your AP exam, the more FRQs we will do, partly because FRQs are probably the hardest part of our AP exam, but there are some that are far more commonly asked, so some practice makes you a little more confident there, a little bit less stressed, and obviously you'll do better. But as we practice these, it's also important that we look at the scoring, because sometimes you guys can do it right, you just don't know certain things that they're looking for some of the points. Okay, so this one says an object moves along the x-axis. So here's the x-axis, and you've got some object. He's moving left and right. When t is 0, he's at position 2. I know that's position because they tell me position. I know it's t equals 0 because they say initial, so that's at the start. That's when time is 0. Velocity during positive times is given by this equation. So they're telling us what the velocity is. And by the way, this is a calculator question. If you don't have a calculator in front of you, you don't need to get up and get one yet because we're doing this one together. But for the one that you do on your own, you'll need to come up and get one. So they give me velocity, and they are interested in what is the acceleration at time 4. So how are we supposed to take something about velocity and then get something about acceleration? Okay, so maybe it would be good to say acceleration is the derivative of velocity. So if I can figure out the acceleration function, I could just plug in 4 into it. Now, is this something that you can take the derivative of? Okay, well, what is it? Okay, y times pi over 3. Okay, and then we could plug in a 4. What is the cosine at 4 pi over 3? Right, cosine is -1/2. So we could say negative pi over 6 for part A. Okay, my question to you is, what's a quicker way to get that answer? This is not the smartest way to do this problem. Right, I told you we're going to need a calculator on this FRQ, which means the whole FRQ is calculator allowed. So even if you can do the derivative, which you should be able to, even if you know what to plug in for and you can do the unit circle, you're spending time doing this by hand and you might make a mistake. You don't need to do that. You need to know if they give you a calculator, they're expecting you to use your calculator, alpha window option 3, this is the one we did last semester, and it can do derivatives if you want to know it at a certain value, which we do in this case. We want to know the value of 4. So the original equation was sine of pi over 3x. Is that right?
Yep.
So why do it by hand just because you can? The answer is -0.524. Now notice there's a trig function here, so your calculator has to be in radian mode, but you should just leave it in radian mode anyway, all the time. Okay, so scroll down. Okay, is there anything else you think we should add for part A? Is our answer there and our justification there? Okay, units would probably be a good idea. Notice though, they don't tell me anything about distance or time units. So if you're determined to put units, area would be, or I'm sorry, acceleration would be units squared per time. But if you don't know if it's minutes, inches, miles, you just have to say units.
Unit over time squared.
Yes, sorry, unit over time squared. And if you don't know if it's second, minutes, hours, you just have to be generic time squared. So that's not a bad idea, but anything else you think we need before I show you that part of the scoring? Okay, so all four of these are real FRQs, so there is real scoring involved here. So this question, they gave only 1 point if your answer was correct, and you could have had negative pi over 6, which you would probably have had if you did it by hand. But since it was calculator allowed, you might get a decimal answer. Just make sure your decimal is to 3 decimal places. Now, they will always ask you to round to 3 decimal places, even though it's not in the directions. So one of these is to the nearest thousandths, and one of them is truncated. They actually will take either one. They don't even care if you round it, if you just truncate to 3 decimal places, but you have to have 3 decimal places. So 1 point for the answer. In this case, I didn't need any justification. That was fine. Okay, part B. Consider the following 2 statements. Statement 1. When t is between 3 and 4.5, the velocity of the object is decreasing, and during the same time, the speed is increasing. Are either of these or both of these correct? Provide a reason why it is correct or not correct. So for part B, statement 1. Okay, so when it says the velocity is decreasing, how would we know if velocity is decreasing? Very good. Not if velocity is negative. That would tell you if velocity is negative. If you want to know if velocity is decreasing, you're thinking about his slope, whether his slope is positive or negative, and the slope / derivative of velocity is acceleration. So the acceleration at time 4, was that positive or negative? We got that from part 1. Since acceleration at time 4 is negative, I would say this is true. The velocity is decreasing. Okay, and then for statement 2, this has been a while, and I thought about having you do these notes again because we haven't talked about this for a long time. The speed of the object is increasing. So what's the difference between velocity and speed?
Velocity is the action.
Good. So speed is just like velocity except absolute value. Velocity can be negative to let you know you're going left or down, but speed doesn't care about direction. It just wants to know how quickly are you moving. So the absolute value of A of 4, because I want to know how it's changing, what would the absolute value of A of 4 be? Positive or negative? Okay, so is it increasing? Yes, that is true also. So they are both true. Velocity is decreasing because acceleration is negative. Just because velocity is decreasing doesn't mean speed is decreasing. It is actually speeding up because the absolute value of acceleration during those times is positive. And let's see how they scored it. I'm trying not to give away the next part. Okay, so number one, for first point, you had to get that the first statement was correct and you had to have the reason. So statement one is true, and we needed to say that the acceleration was negative. Did we do that? Okay, then we got that point. The second point comes from if you knew the second statement was correct. Did we say the second statement was true? Then we got the second point, and our reasoning needs to be true. And I didn't do a great job here. I probably should have added to this. Now the justification, they often list like the most common and most efficient way, but there's usually lots of different ways to get the reasoning answers. But acceleration was negative and velocity was negative. So since velocity was negative, and then we did the absolute value and stuff, it turned around. So could get 3 possible points there. So already, I don't know what the average of this is. When we do AP review, I will often look up the averages of the FRQs for you because I think it gives you good perspective. A lot of times FRQs out of 9 points have an average of like 3 or 4 points. So in theory, if you can just do these 2 parts, you might already be at the average score. So if you can squeak out a couple more points on every FRQ, then you're in really good shape. Okay, back to part C. Now C and D, acceleration from velocity was really last semester. Velocity and speed technically were really last semester. But C and D are specific to this unit. These are very important new concepts for us. And I'm actually going to do part D first, although it doesn't really matter. But what is the position of the object at t = 4? So with integration, and hopefully from our circuit yesterday, you really need to train your brain that you need to start with the starting value, starting position, starting whatever. So where did it start at? Not at x = 0. T = 0. At t = 0, that's the start. But where was he at time = 0?
2.
Right. So his starting value is 2. And then what's the math operation that keeps up with how something changes? I can't hear. Integration. Okay. I really can't hear. I did a hearing test the other day. We talked about sometime. But I can't hear anything. Okay, so what should I integrate from and to?
2 to 4.
Not 2 to 4. I know the value when at time 0, so that's what I want to start at, and I want to keep going until I get to t = 4. So I want to know how does it change from t = 0 to t = 4, and what I should be integrating is velocity. Because integrating velocity gives you the change in the lower function, the change in position, which is what we want here. If you integrated acceleration, it would give you the change in his lower function, which would be the change in velocity. Integrate velocity gives you change in position. So you could put this in the calculator. You could just put this whole thing in the calculator, and this gives us this. You just have to remember that integral is an alpha window option 4. So again, your AP exam will give you antiderivative integration stuff where they want to see, can you do step 1 and then step 2 and then step 3 and then get to the answer. But a lot of your AP exam is conceptual. They're not always going to test can you integrate by hand, but do you understand how starting value plus integration keeps how it changes, and then really the calculator does the rest of the hard part for us. Okay, do you think we need anything else for part D? Okay, how many points do you think part D is worth? This one is going to be worth 2 points. 1 point if we get out to the answer, and 1 point if we set up the integration correct. So 1 point if just this is right, and 1 point to get the final answer. Sometimes I give you a point just for showing that you remembered the starting value too. That's a nice easy point. Okay, and finally part C, which is also super important for this time of the year, since this is newer and will be on our test. What is the total distance traveled? Okay, so I could integrate from 0 to 4, and if I integrate velocity, this gives me the change in the lower function, so change in position from 1 to 4. But here's the problem. As I have this written, this is doing displacement, because sometimes the velocity is positive and it's moving the particle to the right, but then sometimes the velocity is negative and it moves it to the left. This keeps up with the entire change, so if I throw this in the calculator as is, it's just going to tell me how much it moved from time 0 to time 4. I want to make sure I get the total distance traveled. I need stuff to the right to contribute to my total distance, and the stuff to the left to contribute for my total distance. So how do we make sure that everything is going to be positive?
Absolute value.
Right, and you have a calculator, so it doesn't make the integration any harder, but you have to put these absolute value signs here. So you could ask your calculator, integrate from 0 to 4 the absolute value of sine of pi over 3 over t. And when you do that, it gives us 2.387.
Do not add the 2.
Because the 2 is my starting position. So like if I tell you to walk around the room and I want to count up your steps to see how far you traveled, I don't care where you started. You don't have to start at the door for me to know how far you traveled. So, okay, this is kind of a side note, but can anybody think of a different way to get that same answer on part C? Okay, there is another way, and you're going to, hopefully this encourages you to do it the way I've been trying to show you. Technically, if you can figure out the times where velocity is positive, and you add up the change in position during those times, and then you figure out when the velocity was negative, and you add those values, even though they're negative, you make sure that you add those values, and you add up all those values together, you can get to the same thing. So I say that because when you look at the answer guide, they say that you can either do this to get this answer like we did, or if you want to, you could do all of this algebra where basically you're figuring out when it's positive, making sure that it's positive, figure out when it's negative, make it positive, and then add up all those values. And you're going to come out with the same answer, but I don't know why you would want to approach it that way. When you see total distance traveled, you need to think of absolute value and just let your calculator do the rest. They will not ever make you do antiderivative of an absolute value. So that was worth 3 points. So for us, the way we did it, they would give 1 point for the answer, 1 point for showing this. So even though you're going to type this in your calculator, anything that goes in your calculator you should put on your paper just in case. And then because of these absolute value, we get the middle point also. So as I've been saying, every FRQ is out of 9 points. So that's where all 9 of those points come from. And again, I don't remember exactly what year that FRQ was, but most FRQs have an average of around 3 to 4 points. So if you can get 5 to 6 points on that type of FRQ, then you're setting yourself up to do very well on the AP exam. Okay, now, so I did that one for you. I reminded you about total distance traveled. We talked about displacement. We reviewed a little bit of stuff from last semester. But I do want you to do one more of these FRQs as practice with an actual timer. So when you do your AP exam, they always give you an average of 15 minutes per FRQ. So when they give you 2 FRQs, they'll give you 30 minutes to do them. When they give you 4 FRQs, they'll give you 60 minutes to do them. So I am going to do a 15-minute timer, but let's all agree to just do the same one so that we can look at the scoring together. I have the scoring up here. I just didn't print it out for you because it was another 4 pages or whatever. So you can vote for whichever FRQ y'all want to do. I assume you're going to probably pick whatever looks easiest to you, but I will let you choose. So we still have FRQ 1, 2, or 3. Now some people voted for 3, so I'm going to throw that out. We could do 1 or 2. Raise your hand if you prefer to do 1 as a practice. Okay, quite a few. What about number 2? Okay, looks like number 1. Okay, so starting right now, I'm going to give you a full 15 minutes. Again, this is calculator allowed, so feel free to come borrow a calculator if you need it. And even though I don't think you will need 15 minutes, I'm going to give you the full 15 minutes because I need y'all to see that sometimes you quit thinking that you're done when you really should have written down 1 or 2 things that you thought about, and you're missing out on points there. Okay, Johnny, do you have a pass or read link? Your pass. And again, this is a no pressure thing. You're not getting a grade based on your accuracy. Just try what you can do. Write down what justification you think they want. I'm going to share all that with you when the 15-minute timer's up. But you don't need to dig through your binder to look anything up. You don't need to work with your neighbor. Just see where you're at. That's all we're doing here. time's up. So, a couple things is, one is 15 minutes probably felt like a lot longer than you expected it to be. So, if you don't immediately know how to do something, you can calm down, skip that question sometimes, and sometimes when you come back to it, it's a little bit easier. You can certainly work at a pace where you're not feeling rushed and not making careless mistakes. But maybe one of the most important things that you need to do, and obviously I didn't give you any guidance there, but a lot of you probably finished with 5, 7, 8 minutes left over, which is fine. But now when we look at the scoring, if you didn't put down something that you needed for justification, or you had some small error, try to remember that next time, so that you know, oh wait, I've got 5 extra minutes. Let me check for this, this, and this, because I've forgotten those at times. I will also, so I don't want to spend too much class time on going over this one, only because I want you to do the circuit where we can get some practice on distance versus displacement. But I do want to go over the scoring with you on this. And just so you know, these are all real FRQs, so each of these have hundreds, if not thousands, of internet videos of people going over them. So on our class website, I just picked out ones that students have liked in the past, so it's not me going over it or anything, but if you want to hear the breakdown of here's the answer to A, and here's how you do that, and here's the answer to B, and here's how you do that. So we're not going to focus on the how right now. Obviously, if you have something you want to quickly clear up, just leave it out and I'll help you. But let's look at the scoring and help you identify what you did right and what you could have used some of that time on. Okay, so part A, you had to have the answer, that is that the velocity is increasing. You had to say that. And you had to have a reason. So I would say the reason, this is probably the best reason. At 2, the acceleration was positive. If you only had the answer correct, or you only had the reason correct, then you don't get that point. Now again, the reason, honestly, there's probably 10 different ways you could say the reason and get the point, but they always list off the most common and most efficient, and of course you want to aim for most efficient as well. So if you feel like you justified it in a correct way, go ahead and still give yourself the point. Again, it's just the honor system. Okay, part B. Honestly, I don't even remember these questions, what the questions are, but part B, they wanted you to say 1 point if you said at time t equals 12. And the reason is that integrating from 0 to 12 is what gave you 0. Again, I don't even remember what the question was, but yeah.
Is it because it like balances out? Like what's a positive and what's negative? Like the shapes or
Yeah. So the area, so integration tells you how something changes. So again, I don't want to go over too much in this, but we've got some value here. What was this, 55? So integration tells you how something changes. Integration often shows up as area under the curve. So how they got that answer is this positive area is increasing the velocity. This is below the x-axis, so it subtracts. So when this area equals this area, which would be to here, was it t equals 12? Yeah, so this sped it up some and this slowed it down some, but when this area is equal to this area, it's back to 55. Okay, part C was worth the most. Again, I don't remember what the question was. I'm just not too focused on that right now. But 1 point if you said t equals 6. Now if you thought it but didn't write it down, you don't get the point. So 1 point for t equals 6. You had to identify that t equals 6 and t equals 18 as possible candidates, or you could show that v increases and decreases, then increases. So you could do this or this for this point. What does it mean by candidates? Right. Well, and endpoints. This, again, I don't remember what the question was because I don't want to slide back and forth. I don't have a hard copy of it up here. But if you want absolute max or absolute min, they're actually asking you to use extreme value theorem, so you should be testing endpoints and critical numbers. They said if you showed in your work, like a candidates test, if somewhere in your candidates test you showed that you tried 6 and 18, you get that point. Now you should be testing more than that, but they gave a point for that. Yes.
If I only tested 6 and then explained why I tested 6, but just completely ignored 18, I wouldn't get the full point then?
If you explained why you didn't test 18, then that could be correct. Like if you said, I didn't bother testing 18 because I knew it wouldn't be the correct answer because of this, then that's fine. But otherwise, you should be considering it. Something happened in your head that made you realize that wasn't the answer, right?
Yeah.
So it's just a matter of, did you put pencil to paper and explain how you knew that didn't happen to get the point? Okay, and then absolute maximum velocity was a point. So I guess that's probably what it was asking for. And that was what, 115? Y'all got 115 there for max velocity? Okay. So there's the third point, and then last point, did you show somewhere that why 18 was not the answer? So again, you could do that in a sentence. Most of the time when you do extreme value theorem, I would just do this candidates test. Test the endpoints, which was what, 0 and 6? And then any critical numbers, which was like 18 and whatever, wherever it crossed the x-axis. So if you, basically, if you had this over here, and this was, I don't know, 77, but up here this is 115, you're showing that it's not the biggest. So you can count that as not, as eliminating it, because you figured out that it was less than. But if you're not writing anything down, if it only occurred in your head, you don't get that point. You'll have to do more writing your thought process. And again, this is just honor system. Just do the best guess that you think. If you're not sure if you get 2 of the 4 points or 3 of the 4 points, just whichever way you're leaning, give yourself that. It's just a learning experience anyway. Okay, and then part D was asking something about, does the car's velocity ever get to 0? And for this question, they gave 1 point for the answer, never, and then a separate point for the reason. So a good way to say the reason, especially if you just did this candidates test, you should be able to see the absolute max, which is what they asked for in part C, but you should also see the absolute min. I would draw an arrow on your AP exam. Technically, when you're in part D, they're not supposed to, they're only supposed to look at part D section to grade part D. If you draw an arrow up to part C, then they're allowed to look at that and see if that's any more justification. But basically, it's never 0 because the absolute minimum was 10. So if the minimum speed is 10, then it never got to 0. So, and again, if you just show this, then you show why you think the minimum speed is 10. You don't have to show all this, I guess. Okay, so again, just do the best idea of what you can out of grading here. So all of these are out of 9. So again, I'm not grading it for accuracy or anything, but for your sake, at the top of your page, go ahead and write down how many points you think you earned out of 9. The most important thing, and I'm going to bug you to death about this as we do more and more FRQs, it's fine if you got 1 or 2 points. You don't want to get 1 or 2 points on your actual AP exam, but whatever score you got, think about what would be the next easiest 1 or 2 points that you could have gotten. Something that you thought about, you just didn't write it down well enough, something you forgot, but if you relearn it, you could get 2 points easily. It doesn't matter. I don't expect everyone to get a 9 on this type of FRQ the next time you see it. It is reasonable to expect you to do at least 1 point better than this time. So try to find that, try to absorb that information, And then my last question with this, and then I will give you the rest of class for the distance displacement one. So out of 9 points, y'all picked this as one of the easiest ones, you know, just eyeballing it. So out of 9 points, what do you think the average was the year that people took this? This is from 2001, if you care to look it up. I heard 2, I heard 4, 5.
3.
The average on this one that year was 2.4. So most of the time, if y'all had 3, 4, 5 points, you don't usually feel great about that because as a percentage, it's not that high. But on your actual AP exam, if you can get a point or 2 higher on every FRQ, then you're in really good shape because FRQs are usually what's going to bring you down, not bring you up. So again, I've shared the averages because I'm giving you some perspective. Nothing's wrong with the 2, especially if next time you get a 3 and by the AP exam you get a 4 or 5. Then you're in good shape. So, okay, if you did have something specific you wanted me to help you with, go ahead and leave that out. Just to be clear, you do not have to do the other 2 FRQs between now and Tuesday. If you know FRQs are more of a weakness for you than they are for most students, then I would encourage you to go ahead and try them, but I don't expect you to have those done. I do expect you to finish up the number 83 circuit. So please move on to that. Again, I don't think that there's anything new in that. It is conceptual based, so I'm not asking you to do a bunch of integration by hand. Feel free to let your calculator do integration when you can. But I need to give you this as practice to make sure you can differentiate what to do when you need position / displacement versus distance stuff. So I need to finish grading the last few homeworks. I'll pass those back and then I will help out.
Here. Can I share the scene? And then the Khan Academies, I did them on my phone instead of my computer.
Okay.
Can I show them to you?
It needs to be in Khan Academy.
What do I do here?
How did you find, didn't you log in to do them?
When you gave me an email right here, look, there's an email, I said start, and then it brought me to this website, and I did them all through.
Okay, I need to see what they are because you didn't log in because it didn't, look, you don't have scores. You need to be logged in so that it saves your scores because I need to see how many attempts you took and what questions y'all are missing and all that kind of stuff.
So do you want me to just do my computer real quick?
No, just show me on your phone. It's fine. Thank you. It was all 3 of the area things.
Yes, it was.
Finding definite integrals using area formulas, finding definite integrals using algebraic properties, and definite integrals over adjacent.
So here's the, if I click it, it's going to reload the page.
Okay. Still shows your score, doesn't it?
No, not anymore. It's just reloading the page. So that's what that one is.
Okay, then yeah, you got to redo them on your computer though.
Okay.
You need to make sure you're logged in. Because I don't see any activity if you're not logged
You
in.
want me to do it right now?
It's fine, yeah.
So the first Khan Academy I did the last one, then my computer died, so I don't know if it saved my footage or
You were missing one.
Yeah, it was the first one, it was the area, because that was the one that I don't know.
Can you? Is it safe, or can
No,
you do it right now?
I have it at 0. Well, I can do it, but I just don't have it. I have no progress. Just shut that down.
Okay, just do it right now if your computer has power, and then I'll update
She got mad at me because I said something about like don't want to work Saturday.
I remember you were talking to everybody. I remember
I wake up early to start. I say I wake up early to Tuesday, Wednesday, Thursday. It makes me mad. She makes me mad.
Make a big I think there was some weird, I think you need to fix because this was all like
Which one? I got a negative. Just accident.
that's not.
It's 1 plus 1 plus.
I feel like I remember being like some area.
I mean, we get so and then you just get 1 minus negative 4, which is negative.
How'd it go? How'd the FRQ go?
It was, I feel like I just had a lot of like unfinished thoughts. I was just like really like what I like previously know. It's just like maybe there, but then I'm like I don't exactly understand what this is.
Did you get a 4 out of 9?
I think so.
Oh.
I got it. But I did do it just because I got the first one totally right and then I got part of it. Yeah.
Okay. I'm just curious.
But its velocity could be negative, but it's not just feeling. Well, I guess if you had the
This is asking about the initial velocity, but it says that if we put in 0, it would be wait, no, never mind. Here.
Okay.
So, like I have the last.
When does it move into the right? Yeah. So when is it going to be moving to the right?
Well, we're trying to figure out if it's moving to the right.
Oh, my bad. Okay. So velocity's negative at 1, so you think it goes to the...
Well, I don't think you can figure it out just because.
Sure you can.
But it can't, like it's just slowly moving right.
You're thinking acceleration. If velocity's positive, it's either going right or up. If velocity's negative, it's going left or down. That's the difference between velocity and speed. Speed doesn't care about direction, so it's just always positive. Whereas velocity could be negative so that you know it's going left or down, depending on the context of the question. So yeah, basically, if velocity is really negative there, then it's going to the left. That's all you need. If you remember, I gave you last class, this one, right? Yes.
I did check it.
Yeah, there's a couple.
She'd just be lying.
I don't like.
Got a 3, man.
I don't know if you just heard our conversation, but we were talking about.
Number 3, we got, it was the one with the 18.
We haven't done 3 yet.
I don't know.
No, saying like the
Yeah, he
answer.
asked which one we got to make sure he didn't get the wrong one. Because remember, we all thought we got like the right one on the last circuit.
Yeah, but
Wait, what did you guys get for two?
For 2, we got -1, and it moves to the left on the graph.
Okay, everyone's 6. Oh, okay.
So yeah, we just derived this in acceleration formula. So I don't like deriving.
You don't derive it, you integrate it.
Derive it at all?
You're trying to find the acceleration. Oh, wait, no, you did.
You turn in because it's
No, you're right.
yeah.
I just forget how to do math. Wait, I already did that.
I'm about to go finish grade time. Now you need to catch up on the other 20 minutes.
You're looking number 5.
Yeah. Like, I'm on 3, man. I don't.
Yeah, you want this one?
Yeah, no, I'm still.
Yeah, stop.
Yeah, I'm just.
No, I'm on 4. So what you get on 4?
I got 14.
I think I'm doing too much.
I got that one.
Oh yeah.
2 plus 64. Gabby, let me know how you do 3. Wait, what is oh. Yeah. Wait, how do you know that?
I'm trying.
I thought of it like a people like this, so I said like this to 0 on the
Okay.
I got 11.
Okay.
And like, am I
How
going
do you know, based on velocity, how do you know if something's moving to the right or not? Okay. So what I would think is the most efficient, since you have the calculator, I would just graph this and then just look at the part of the graph that's positive. So again, it just depends on if you have the calculator or not. If you didn't have the calculator, what you did was you figured out where it was 0, so you know where it might be switching from positive to negative or negative to positive. So you could have plugged in a number to the left of it and to the right of it, and you could have seen.
Yeah, so
Yeah, that would be fine too. But again, you've got a calculator, so just let it do the bulk of it.
the answer to 5 is I got 5.25.
This what? There's no way you're.
I don't know what I'm doing wrong.
That looks like 5 out of 10. That's so.
What's your derivative?
It is 3t squared minus, in parentheses, negative 16t minus 16 over,
Okay, I got it.
over t plus 1.
Thank you. Hungry. What are you doing? Got back from So you're going to go back to the chiropractor? Well, if you go back to the chiropractor, you would not be.
Whoa.
Like, this is such like. Oh, usually put my face on the floor. Like, I was so just.
Really good.
It's negative 32 divided by 16.
No, because you went on.
I guess it just is very varied.
Yeah, they're not all the same.
I did them just I like the part. My favorite is the cheddar.
I like the I'm lucky. Why am I Wait, I'm still not doing this right. Did you
Yes. I got it.
Right here.
Oh, yeah.
You try to integrate this. Whatever you do, so I have that integrated. Check it.
Or the
That's not, we don't it's not when we have memorized. It's not a power rule. So you're certain only the options.
I'm just gonna say, hey, I graphed it.
So just look at the calculator. You don't need to try that. Again, this is more conceptual. I want to know, you know, starting value plus integration. Yeah, you calculate it.
Okay, I'm about 1 minute away from being done with the homework, so if you have something you're stuck on, give me just 1 more second, and then I'll come around. Okay, if you need my help, just raise your hand and I'll come over to you.
Oh, yeah. Come on. Yeah. Take from well, like, for what do you mean? Whenever it's positive. Well, you like, from like the 0 to 6, which is 6 is like right here. So you're using, so what I did y equals, I did another line. Would you agree that this is a line of y a0? They graphed it, zoomed in, converted to like here.
about like 20 or 30 years ago.
Like now I can see it's positive right here for a short period, then it was positive here. So I just, and then I did like second out, and then intercept. And then found like where it crossed here to here, and then here, it stays positive all the way until 6. So it's all the way until 6. So I got 1.572, yeah, it's
I did.
How do you do that? I get 9 travel this.
Otherwise, you're really trying to
Oh, really? That's
it's moving to the right and velocity is positive, but if you have a calculator, just graph it to figure out my car.
Because it was on the left
It's not
side.
attached to it, it's like one part.
That's not just last week.
No, it doesn't tell me anything. It just says a Pathway Derby car acceleration from the west.
All I had to do was,
And this one was in the last week.
so which one are you trying to do?
This one was like, I just did it.
I have it off.
Is the concept.
It might. It's just that, usually whatever the other hand wants to do.
These kids are also evidence based.
I like
You like my slippers? They look like my. No, they're LLB.
I didn't concept before. See, that's what
Yeah, I got them for
typing it
Christmas.
in too.
And
You step in some water and your lips sweat off.
look at those bottoms. Those are ready to face the wear and tear of the outside. But look at them. I don't know. How am I supposed to know what's going
If
wrong?
you step in a deep puddle,
Well, I use my eyes. Oh, I don't think you want to step into a deep puddle no matter what shirt you're wearing.
that's true.
I noticed I was at about 30. But all I know is that you'll.
Oh, okay.
So this one?
What?
Like to go for acceleration.
What did I do wrong?
And then you got the velocity. And then he just moved it.
Wait, where's my line?
Integrate this.
How do I do
Velocity.
six? Wait, what did you do? Oh, I didn't know.
Zero to 6.
Yay, I got that. Wait, no, I didn't. Gabby, have you done this? Is there a way to get it to look at this? Like, is there like
We had one like this, but you didn't like give us
Yeah.
Well, it does say term rest. So that inadvertently is telling you that T is 0 is that position, this is that position 0. So it's kind of like giving you a point.
Oh, no, none of those. T-2.
So wait, I have it. So it's like they give you this
I don't know what 9.33 is.
Well, nothing's free.
and then this is
I don't think you can do that. I think you need to do that anti-derivative of rest by hands first.
so I have like a
So we know velocity tells us where.
It's 1 and 0, 0, you can solve for the T in the velocity.
Yeah.
is that
And you can let the
So,
calculator number, and it's gonna move all variables. So the second time
that's what I did on following the other circuit, and that's what I did.
Okay, so I graphed it. Is this what the graph is?
This is like an X.
What?
Maybe. It looks similar, right?
Now, I don't have problems.
That's what you set it up.
Oh, no.
do I just find these ones?
Yeah. I don't know why yours looks different. The answer is this one. The answer is I think so, yeah.
I'll figure it out.
Yeah,
I guess that's
this
the one
one,
that makes sense.
this one can't be the answer. This one can't be the answer because we're only worried about the 6 and there's 8.
Okay.
That is included on this.
No, because
Yeah, we should do another bake sale.
the DTN.
How's that possible?
I tried.
In front of you. I'm not saying it's bad. That's why I call it out. I did that on the whole
Wait,
Okay, so when would a particle be moving to the right? So why not just graph the velocity and look at where it's velocity? Okay, you did. But
okay, raise the rating.
well, notice this question. What do you care about? You only care about 0 to 6.
Yeah.
So it's definitely positive from year to year. How do you find that?
Constant equals 4.
Okay, good. So you can do that. Now that's going to be a decimal, but it should be a decimal that's more than 3
out loud. Trying to do it.
Now right here, it's like you have a zoom in a little bit. That's what I was thinking. Alright guys, it's about that time. If you borrowed one of my calculators, I need it back. Don't forget, no school Monday, so that means Tuesday I will see you again 3 days in a row. Make sure you finish up the circuit. You do not have to finish up the FRQs. The class website has most of these worked out as videos, so utilize that resource please. Have a good weekend.